So you have some givens. The projectile fired off the cliff has an initial velocity of 65.0 meters per second. It's fired at an angle of 35 degrees. We're going to say that the acceleration in the y direction is negative g, and then we can say that y initial is going to be 115 meters. So it's being fired off the cliff. We're going to say that the cliff is 115 meters high, so that's our y initial. Part A wants us to find the time taken, so we can say that y final equals y initial plus vy initial t plus 1/2 of gt squared, or rather minus 1/2 gt squared. And so we can say to find time, y final is going to be 0. So it was 0 equals 115 plus, and then this would be 65 sine of 35 degrees, and then minus 4.9 t squared. This is a quadratic equation, so we can just simply solve using a solve function in your TI 84, 85, or 89. T equals 9.964 seconds. We're also getting another answer, negative 2.3655 seconds. We're not going to use the negative answer because time, of course, can't be negative. So we'll be just using t equals 9.964 seconds. This is your answer for part A. And for part B, they're asking us for the total displacement in the x direction. So we can say delta x equals Vx initial t. So this will equal 65 cosine of 35 degrees, and then times 9.964, and delta x equals now 531 meters approximately. So that'll be your answer for part B. And then part C, they're asking us for the Vy final. So we can say that for part C, they're asking us for the x and y components of the final velocity. So Vx initial equals Vx final, and this will equal 65 cosine of 35 degrees, and we are getting 53.2 meters per second. Our Vy final will equal our Vy initial plus gt, so this will equal 65 sine of 35 degrees, and then this will be plus negative 9.8, and then our time of 9.964, and we are getting negative 60.4 meters per second. Part D, they want us to find the magnitude of the final velocity. So we can say that the magnitude of the final velocity will simply be equal to the x component squared plus the y component squared, and then taking the half power of the entire thing. So we can say 53.2 squared plus negative 60.4 squared, and then the entire expression to the 1/2 power. And this is giving us 80.5 meters per second. And part E is asking us to find the angle measure. So we can simply say the arctan. Now, tan is opposite over adjacent. So here it's going to be the y value divided by the x value. So it'll be negative 60.4 divided by 53.2. And so our arctan of 60.4 divided by 53.2 is going to give us 48.6 degrees. Now we have an x component that is positive, a y component that is negative, which means that we are in the fourth quadrant. So it'll be 48.6 degrees below positive x-axis. So fourth quadrant. And then they're asking us for the maximum height reached. So we can say that for f, Vy final squared equals Vy initial squared plus 2 times a sub y, and then here it'll be y final minus y initial. So we can say that y final equals y initial plus vy initial squared divided by 2g. And at this point, we can say this is going to be equal to 115 plus vy initial, so it'll be 65 sine of 35 degrees squared divided by 2 times 9.8. And we're getting that y final, or equals y max, essentially. And this is giving us 185.9 meters. So this will be our y max. That is the end of the solution. Thank you for watching.